In this video, we're going to use desmos tables to explore the behavior of a function near an undefined x value. In desmos, I've already defined this rational function f of x that you see pictured here. We see that the denominator is x minus 3, meaning that the function's undefined when x is equal to 3. I'm now going to go ahead and add an input-output table by hitting the plus sign and selecting table. I want to create a table that inputs x and outputs f of x, as we've already defined in desmos. I'd like to explore the function near that undefined x value of x equals 3. Notice if you plug in 3, desmos does return undefined because that would cause division by 0. But we could explore the behavior on the left side of x equals 3 as we get very, very close to x equals 3 in order to numerically explore the y value that this function is approaching. So for example, I could pick x is 2.9. That's a value on the left side of x equals 3, which is very close. I could plug in x is 2.99, which is even closer to x equals 3. I could explore 2.999 and 2.9999. These x values are approaching x equals 3 from the left. I'm going to go ahead and go over to the graph and zoom in on that a little bit so you can see those points. You see that the x values that we plugged in there, x is 2.9, x is 2.99, x is 2.999, they're so close to x equals 3 that visually on this graph you can't even tell the difference visually. They're so close. And we see that the y values are getting closer and closer and closer to a y value of negative 4. The closer we get to x is 3, the closer the y values get to y of negative 4. But remember that this function will never actually attain a y value of negative 4 because when x is equal to 3, the function's undefined. So there are points on the graph on the left side that get closer and closer and closer to the point 3, negative 4, but they never actually attain the point 3, negative 4. Let's do the same thing, but let's explore this from the right side of x equals 3. I'm going to click the plus sign and select table. And again, I'm going to plug in x value and output f of x values. And again, if you like, you could start your table off with that undefined value to remind yourself that it's not defined yet. I'm then going to plug in x values that are just slightly bigger than x equals 3. They're on the right side of x equals 3. So that would be things like 3.1. And then if I get closer, we would say maybe 3.01. If I get closer than that, 3.001 and 3.0001 and maybe 1. All right, the closer and closer we get to x equals 3 from the right, again, we see the y values are again approaching y equals negative 4, but they'll never actually reach y equals negative 4. So I could now, in desmos, add one more thing to this graph to make it very clear. I'm going to actually turn these points off so that on my graph we don't see those points anymore. Notice how I did that. I went to the table and I selected the little picture next to the f of x, and it unselected those points as being things included in the graph. And then I'm going to come down and I'm going to add something new. I'm going to add the point 3, negative 4 to the graph, and maybe I'll label it as well. But I'm going to come over here and hold down my left cursor, and I'm going to make it an open circle because that is what's happening on the graph. The graph attains all those points as near as you like to x equals 3, but it will never actually reach the point 3, negative 4. That is a hole in the graph.